Okay, so we've been working with a lot of different things with right triangles, and in yesterday's videos, a lot of times I would stop and run through the fact that if you have a right triangle, you have options for what can be done. So I'm going to look at this first one where I'm finding a missing side length, and it is a right triangle. That is very important to notice, is the fact that it is in fact a right triangle. So because of that, it's possible we're going to do either trigonometry or the Pythagorean theorem. So we need to look what else we have. When you have two side lengths and you're only looking for a third, and none of the acute angles are cared about in any way, when that's the case, you're about to do the Pythagorean theorem. So I do still need to care about where the hypotenuse is, but I'm not going to label opposite adjacent hypotenuse. I'm just going to say, okay, this is the hypotenuse. I'm going to use this in the Pythagorean theorem, a squared plus b squared equals c squared, where c is always the hypotenuse. So in this case, I'm going to have x as my hypotenuse. So the 12 and the 9 will serve as our A and our B. So I need to do 12 squared plus 9 squared, 144 plus 81. I'm getting 225. Now that's actually a perfect square, which is important because I'm going to cancel out the squared by square rooting. If you were thinking like, oh, I have no idea, but it ends in 5, everything that ends in 5 can be divided by 5. You could still go through our simplifying radicals process to figure this out. You would get 45, so you get a prime number here, composite here. 45 is 5 times 9, prime, composite. 9 is 3 times 3. So what you would end up doing if you would break it apart is you would have 3, 3, 5, 5 for your x, and since pairs make perfect squares, you could say, well, the square root of 9 is a 3, the square root of 25 is a regular 5, and nobody's left over inside the radical, which means that side length is just 15, which is the square root of 225. But if you didn't catch that it was a perfect square, you can figure it out that way as well. Plus, don't forget, algebraically, we should have 2 solutions on this, but we know better because we just found the length of a triangle and it's not going to be negative. So 15 miles is the length of x. So for number 2, really, really similar. Yes, it's a right triangle. However, there are no acute angles given. None of these are labeled. So because of that, our only hope of finding a missing side length is Pythagorean theorem, because we do have 2 of our 3 sides. The important one to identify first is the side across from the right angle. Our hypotenuse will always go in for C. So last time it was the x. This time I'm putting a 15 in for C. The other 2 legs serve as our A and our B. So I'm going to go ahead and have to individually square these 2 and write them down. But I can't solve yet. So I'm going to have to try and get x by itself. I'm solving by square roots. So I'm going to subtract 25 first, which is getting me that x squared is 200. And now I need to solve this by square roots. 200 is not a perfect square. I'm trying to think. I'll do it down here. 200 is not a perfect square, so I'm going to break it down. So it is 2, a prime number, times 100. 100 is 10 times 10. 10 is 2 times 5. So there's 2 more prime numbers that can't be broken down any further. So instead of square root of 200, I would have the square root of, there's 1, 2, 3 2's and 2 5's. Pairs make perfect squares. So instead of the square root of this 4, I'd have just a regular 2 instead of the square root of 25. What are you going to ask Dad, Eloise? Is it something that is a bedtime question, or is it something you would wait till morning? I'm in the middle of a video right now. What do you need, Eloise? You can. Go lay down. Listen to your story. 2 times 5 is 10. Square root 2. Again, don't forget 2 solutions algebraically. 1 solution when we are talking a geometry problem of finding length. So yes, we have been dealing with trigonometry, but that